Hello everyone, I'm Arnold Jonker. Welcome to term 4 presentation. And this term I developed a app. In my first term, I designed and built a zombie box that reduces the noise of generators. Second term, I expand on my first on the same zombie box to build a controller to control the condition of the inside the box, zombie box. On my third term, I built a packer that increases um, production, the production. In term 4, we learn to program in Python. My problem statement, I've bought a small controller in my second term that can adapt in any environment that is exposing. Problem statement is the, to design and program a Python-based cell phone and laptop application to measure temperature and humidity in any growing enclosure to create optimal growing environment to increase yield in indoor farming. Solution. My solution is to design and program a app that can read data from a server where the smart controller stores of the data. As long as you have internet access on your cell phone or laptop, you will be able to monitor it from long distances. Remote application. The device can be applied in houses, greenhouses, enclosures or factories. And it's designed to handle harsh conditions. How the works? There's a THT22 temperature sensor. It's a sensor that measures humidity and temperature. I also used a three-color LED to see if it's connected on the server. A ESP32 to control the to connect on the server. Breadboard to connect to make all the connections so it can work. The THT22 temperature humidity sensor gathers information from the humidity and temperature and humidity and of the enclosure, and then send it to the ESP32. Then the ESP32 is connected to the server broker. Then the application is connected on the same server broker to read the data that's been stored on there in the form of cases. It's a app the app is unique to my design project and my second term too. Here's my hand sketches of my design project. my icon and the layout of my app is gonna look like. Here's my CAD sketch of my app, of the gauges in my app. I actually did not have alternative considered. I took the base options and I went with it from the beginning to the end. Here's my project testing. I use a multimeter to test the accuracy of my app. Here's all the tools I used. Software used: Python, Tony, and MQT Explorer. I used it in the previous slide. I use a multimeter for testing. In Python, there's all the libraries in Python and MicroPython libraries. Skills used. Experience used is to wire up a ESP32 and troubleshooting hardware. Experience learned is Python programming, MicroPython, server client setup, troubleshooting Python code, and program troubleshooting. Assembly sequence. I started with programming the app, then programmed the device, established a connection to the server, tested if it was working, created a flow chart, checked data accuracy, done some debugging, and turned it into a exe launcher. There's all my research that I applied. How to work with MQT Explorer, how to publish and subscribe messages, how does the Kinder work, the basics of MQT server with Python, and how to install Mosquito Python broker on Windows and initial testing. It helped to make my app work properly. My research helped me to understand more of what I'm doing and to make it to work properly and faster. Here's my activity log. Most of my time went to my project, and the second biggest one is my theory. The third one is PPT. The bottom small one is my practical, and the top one is the extra stuff I've done. The most impactful PPT that I had this term is commit 100% on what you're doing, what you do. If you don't commit 100% what you want to do or must do, then you will never get anywhere. And if you commit 100% and No one will be able to distract you from the path you're on. Yes, the difficulties that I faced in the development process of my application. The cases did not work. The bases did not change properly in the beginning. The setting space were duplicating on the same page. It did not affect my timeline of my project. It happened in the early stages of the project, and it did not affect the quality and the performance and quality. Um, I've learned how to program in Python language. Troubleshooting Python code and how MQT server works. Lesson learned. I've learned that it is easy to program an app with minimum knowledge, but it's still hard to make the app work properly. Future improvements. To improve the performance and graphics, remove some minor bugs, make a APK version for the cell phones, and add more features like a text box for the database, so you can find easier the data that you want of a certain date and time. Sorry. It make both of materials. That's labor. Right. My flow chart. It takes you to if you open the.
Just go one back, please.
Oh. Okay. That's right.
Thank you.
If you open the app, then it's gonna take you to the login page. That's gonna ask you for your username and password. If you leave it blank or is incorrect, then it's gonna refuse you to go to the main page, and it's gonna take you back to the login page until you enter it correctly. If it's correct, then it goes to the main page. Main page. There's a menu window that takes you to a settings that has settings, database, logout and close buttons, and next to it is gauges. It's connected on every 10 seconds it gets new data from the server, and it displays the data. Here's the rest of the flow chart. The process start program is the ESP32 is connected on the MQT's broker. The start button is to start the program that's on the ESP32. And to see if the ESP32 is connected or not, here comes a three-color LED that I mentioned earlier. The red one is to indicate that it's not connected to the server. The blue one is in the process of connecting. The green one indicates that it's connected to the server. And there's a humidity and the THT22 temperature and humidity sensor that's also connected on the ESP32